Welcome to Altair Engineering. I am apoorv.bapat. Today in this video I am going to discuss about the solution of part A, pressure tank, which has been a contest model of AOC 2012 India. So let's start with the problem definition and inputs provided from our side. So a pressure tank of dimensions 200 by 100 by 150 mm is subjected to an internal pressure of 2.5 MPa up to a height of 125 mm from the bottom. The tank is 2 mm thick and is resting on the ground. The modulus of elasticity and Poisson's ratio are 2.1 e to the power 5 Newton per mm square and 0.3 respectively. The solution expected from the students, or you can say a concept design, are the points where you have to use hyperwork student addition to optimize the designs of pressure tank to minimize the displacement at the center of each face of the tank by creating reinforcement beads using topography optimization. And also we have to provide two other design options with different bead patterns and compare their design performance. So actually we have to create 3 different bead patterns and see the results of displacement for from the actual one to these three different ones. So let's start with solving this model in HyperWorks Student Edition version 12.0. So this is the GUI of HyperWorks Student Edition version 12.0. Select the user profile as OptiStruct. If you are using HyperWorks version 12, select the user profile as radius. It will load the required templates to help them to solve this model. Then click on open folder, browse the file, so this is the file of pressure tank. If I click on this icon, that is shaded geometry and surface edge, so that you can see the surfaces. Now as per the problem definition, the tank is subjected to an internal pressure of 2.5 MPa up to a height of 125 mm from the bottom. So what I have to do is I have to create a split line on this surface at the height of 125 mm. So to create that, first I will create the nodes. So go to geometry, nodes. On geometry page, click on nodes. Select the fourth option, that is extract parametric. Select the line on which you want to create the nodes. Enter the number of nodes as 3 and click create. So I have 3 nodes on this particular line. Now click return. Now again on geometry page, select distance panel. Select these 2 nodes in 2 nodes option, and in the distance panel enter the distance 125. So the distance between these 2 nodes is now 125. Always make sure the node which is in blue color will move. So you have to select that node accordingly so that the blue color node should move. Now again in the geometry page, now I have to create a split line. So go to quick edit panel. In this, select split surface line. Click on the nodes and toggle this option to make from line to lines. Select this node and click on the other edge. So it will create a split line on the surface. So in this way I have created a split line at the height of 125 mm from the bottom. Now click return. Again click return to go back to the main menu. Now click on geometry page temporary nodes to remove the nodes which we have created to create the split line, and click on clear all. Now the next step is, before meshing, to create a design and non-design space. So this particular problem we can solve using 3-4 different methods. Like, we can create the design space for the top and the side walls. We can make this as a non-design space, the top and bottom both as non-design space, and make the side wall as the design and do the optimization. So we can use different options. So what I'll do is, initially I will only make this first one, the side walls, as the design, and rest other as the non-design, and perform the optimization. So I'll open this component browser, create one more component as non-design. So to create a component, click on component collector icon, enter the component name, make sure the radio button create is selected, enter the component name as non-design, select a color, with no property click on create. So it will create one more component. Click return to go back to the main menu. Now go to tools page, and on tools page select organize. Make sure the collectors option is on. From the toggle, select surfaces. Select the surface which you want to move and make that non-design, and click on move. So now these components, these surfaces are in non-design component, and the rest will be a design component. So click return to go back to the main menu. So till this everything is done. So now we will do the meshing. So to perform the meshing, go to 2D auto mesh panel, select all the surface at once by clicking surface all. Make sure the size and bias panel is selected, interactive option is toggled, enter the element size to be 5, mesh type as quad, element to surface component first order, keep connectivity, and click on mesh. We will finalize this mesh as it's look good, but before finalizing we will just check the elements quality. So warpage, it's fine, aspect ratio is fine, minimum angle quad is perfect, maximum angle quad is also in the range, length it's okay, Jacobian it's fine, minimum angle tria is fine, and maximum angle tria is also perfect. So I will click return to finalize this meshing. So my meshing is done. As you can see, I will off this surfaces. To off the surface, just click on this icon. This will turn on, off and on the surfaces. So my meshing is done for the design and non-design component. Now I will click return. The next step is to create the material. So I will now create material as, I will name it as steel, define a color, select the type as isotropic, card image matte 1, click on create edit, enter the value of E, new and row, click return, again click return to go back to the main menu. So on the model browser you can see my material is created. Now the next step is to create the property. So I will enter the property name as design, select a particular color, type 2D, here type means the type of meshing you have done, card image P shell, material will be steel, click on create edit. In the problem definition it is said that my tank is 2 mm thick, so I will enter the value of thickness to as 2 mm, here. I will create one more property as non-design with a different color, same type as 2D. Card image will be P shell, material will be steel. Again I will click on create edit. Again I will enter the thickness value as 2 mm. Then I will click on return, again click on return to go back to the main menu. So now you can see my property is also defined on the model browser, you can see, for a non-design and design. So I will assign this property to the components which I have created. So to assign it, click on component collector icon again. This time instead of create, select the radio button as update. Click on the comps, select design, click on select. Toggle the no property to property. Click on property and select the design property and just click on update. Similarly, comps, non-design, select, toggle it to no property to property. Click on this property and click on non-design and update. So now I will cross check it whether the elements have assigned the proper material and property or not. So here the elements are shown by the color of component. I will see it by the color of property. So if the color of property is getting, that means the elements have received the property or desired properties. Similarly by material. So my elements are assigned with proper material and properties. Now the next step is to define the loading conditions. So to create the load collectors, first step is to create the load collectors. So to create load collectors, click on load collector icon, enter the load collector name as pressure, define a color and click on create. We will create one more load collector as SPC to define the constraint. SPC stands for single point constraint, and click on create. So on the model browser you can see two load collectors have been created. One is pressure, one is SPC. So I will click return to go back to the main menu. As you can see, my SPC is in bold, so it is a current load collector. So I will first apply constraints on my model. So as per the problem definition, my pressure tank is resting on the ground as it is mentioned here. So I will apply the constraints on the ground. So I will go to analysis page. On analysis page, I will click on constraints. Select the node, click on nodes by phase. Make sure all the degrees of freedom are checked and the load type is SPC, and click on create. So my constraints are created. As you can see, the size of the constraint is this. So if you want to increase the size of this triangular face, you can do that from here. So a bigger triangle you can see. Now I will apply the pressure. So to apply the pressure, I will first make the pressure load collector as the current load collector. So I just right click on that and click on make current. Go to analysis page. On analysis page, click on pressures. Press shift left mouse button and drag the window. So all the elements for the height of 125 will get selected. If you don't want to use this selection option, go to elements, by geometry, surfaces, and select these surfaces and click add to selection. So all the elements here will get selected. Similarly, nodes, by geometry, in the same way you can select the nodes here also, add to selection. So these nodes will get selected. The magnitude of the pressure is 2.5 MPa. So I will enter the magnitude as 2.5. It's normal to the elements. The size of the arrows. Make sure the load type is pload 4 and click on create. So now I have to just check whether my pressure is internal or external. So it has to be from inside. So it will show the arrows. You can see with this arrow representation, the pressure are from inside. So if I on this is the meshing and my pressure is from inside. Now the next step is I will click return to go back to the main menu. Now the next step is to apply the load step or to define the load step. With the load step I can we will define the type of analysis which we are going to perform using OptiStruct. So to define the load step, click on analysis page. On analysis page, select load step. Enter the load step name as pressure tank. Select the type as linear static. Check the box in front of SPC and load. Click on is equals to sign and select SPC in front of SPC. Similarly, select equal to sign at front of load and select pressure and click on create. So on the model browser you can see a pressure load step is also defined. Now I will save this model as model. I will create one more folder as base run and click on save and perform the analysis. So to perform the analysis, I will click on analysis OptiStruct. Select export option to all, run option to analysis, keep the memory option as default. So export option to all, run option to analysis, memory option I will keep it as default and click on OptiStruct to start the solver. Once you click on the solver, it will open the solver window. As you can see, a message has appeared that analysis is completed. So I will click on results to view the results. So I will just close this message log. This is not an error, it's a message log. So I will just close this and view the results of displacement. So my displacement value, to find the displacement value, click on measures icon, check the box in front of static min max results, turn off minimum and check only maximum. Before that, click on contour and just click on apply. So my maximum displacement is coming at node number 2452. So now I will perform the optimization to reduce the displacement of node number 2452. If the displacement of that node decreases, so the total displacement will also get decreased. So I will again move back to the Hypermesh GUI. So I will click return to go back to the main menu. And now we will see how to set up a topography optimization. So to enter to optimization panel, go to analysis page, optimization. Select the first we have to define a design variable. So to define design variable, click on topography. Enter the DES VAR. DES VAR stands for design variable, name as topo. From properties, select design and click on create. Then go to beat params, that is beat parameters. Select the design variable topo. Enter the minimum width value as 10. By default, the minimum width is coming as 0. So This parameter controls the width of the beads in a model. The recommended value is between 1.5 to 2.5 times the average element width. So my average element width is 5. So that's why I have taken twice the minimum width of it. Then enter the draw angle as 75 degree. So draw angle controls the angle of the side of the beads. The recommended value is between 60 to 75 degree. I will explain you in some details that is what is draw angle. Let's assume it creates a bead something like this. So this angle is the draw angle. So 60 to 75 is the range. Then enter the draw height as 5. This parameter sets the maximum height of the bead to be drawn. So if it creates a bead like this, so the maximum height of the bead, I have entered this value. Check the box in front of buffer zone. So this parameter establish a buffer zone between elements in design domain and element outside the design domain. So the smoothness of bead should be maintained. Then set the boundary to skip boundary skip option as skip SPC. So it will not create a bit where the constraint is done. So it will apply the beads only or create the beads only in the other portion, not the portion where the constraint is applied. Then draw direction will be normal to elements. So the beads will be coming outside. Or you can define the direction, which direction the beads you want. And click on update. Then pattern grouping. So pattern grouping will help us to define the patterns of the bead parameters. So first click on DSVAN and select topo. Click on pattern type and select planar. There are different types of patterns. So I will create, by changing the patterns you can get a different designs of beads. And first node as this, second node as the other one, and click update. So this is the first pattern on which I want to create the beads. Click on bounds and make the upper bound as 1, lower bound as 0, and click on update. So let's check whether I have created the patterns, bounds and everything. So the upper bound sets the upper bound on the grid movement equal to upper bound multiplied by highest grid movement, and the lower bound sets the lower bound on the grid movement equals to lower bound multiplied by HGT. Then click return to go back to the optimization panel. Then the next step is to define the responses. So enter the response name as displacement. Select the response type as static displacement. Select total displacement. Click on the node by ID. We will see which one is 2452. So I will click here, node by ID, and enter 2452. So it has selected a node. If I turn on the number, it will show me the number. So I will cross check it, 2452. The node number is correct, and click on create. So my design variable and optimization response is set. Now the next step is to define the objective. So as I don't have much constraints, my main constraint and objective is to minimize the displacement. So I will directly apply to decrease the displacement as objective. So I will click on objective to define. My objective is to minimize the displacement and select the load step. Click on create. So in this way an objective is defined. So my first optimization response is set. I will click return to go back to the main menu. I will go to file, save as model. So topology 1. Again I will perform the analysis. Go to analysis, OptiStruct. This time, instead of run option as analysis, I will make it as optimization, so that it will perform the optimization analysis, and click on OptiStruct. So it will start the solver window. It may take some time depending on your hardware configuration. So as you can see, the optimization has converged and feasible design has achieved. So instead of clicking on result, I can click on result and open a new hyperview. I will use the same hyperview and split the window into 3 different segments and open the file. So to split the window, use this command. Click here to open the file. Topo H3D, apply. Again this. So there are 2 H3D files. One is part A tank underscore des.h3d and other one is part A tank s1 underscore s1.h3d. So des stands for design variable, that is the optimized shape, and s1 stands for the load step, the load collectors, that is the displacement and stress value. So apply. So this above value will show me the shape changes, and the below image will show me the displacement values. So I will select the last iteration, go to contour and click apply. So this is the shape change. Similarly, last iteration, displacement, static minimum. So it has reduced the displacement, and this is the pattern. So this is the one shape which I have got. Now I'll go to again hypermesh to get 2 more shapes. So to get the 2 more shapes, I'll click return, analysis, optimization, topography, beat patterns, pattern grouping. This is the pattern grouping, so I will change this to from here to here and just click on update, file, save as model, topo 2, the second one, run this one too with the same options. Just changing the pattern grouping will change the beat patterns. So my optimization has converged, so I will close this. Now I will divide this into further more segments. Topo 2. The DS one is the shape optimized one, and the other is the load step one. So this is the last iteration. Click apply. This is the second bead. I can turn the message, and the displacement value. For the last iteration. So it has reduced the displacement drastically. So the first bead reduces the displacement to 18, but the second bead reduces the displacement to 5. Now we will use the third one. For the third, I will do some more changes. So I will make one more component as design 1, click create. One more property as design 1, type 2D, card image P shell, material steel, create edit, thickness will be 2. Update the new component, that is design 1, with the new property. Now I will go to tools, organize, and move these elements to design 1. So these are the design 1 elements. Now I will go to analysis, optimization, topography. I will create one more as topo 1, give the property of design 1, click on create. Beat parameters, minimum width will be same, draw angles will be same, draw height also will be same, buffer zone, boundary options, load and SPC will skip, click update. Pattern grouping, planar, selecting these two as anchor and first and click on update. Then bounds, select topo 1 and click on update. So I have just edited some of the changes and let's see how it goes. So topo 3, that is the third design, analysis, OptiStruct, optimization. So it is solving for the third design. Till the time it's solving, I will split this into some more. So my optimization has converged. So I will open a new design shape. This is the design shape, and this one is the results value. Apply. I will turn off the nodes so I can see the image well. Apply. So you can see these are the different beat patterns. So I have got a beat pattern at the top as well as at the bottom. If you want in the side also, just add one more property, one more component, add one more design variable, define it differently, run the optimization, you will get one more option as the design variable. So you can create as many beads as you want and get the desired shape. What I will do, just to fill this up, I will create one more. So optimization, topography, pattern grouping, topo. I will use the diagonal one from here to here, update. And for this, I will use this to this, from here to here, update. And save the model as save OptiStruct, OptiStruct. So it's solving. It will take a couple of seconds to solve or a minute to solve, few seconds to minute depending on your solver capabilities. So my analysis is done. I'll go to fourth one. This is the design, and this is the displacement value. So turn off, shape change for the last iteration, displacement value. So these are the 4 different shapes and these are the values of displacement which I have got. So generally what I suggest is, the presentation, please keep watching the other videos. Once I'll solve all the videos, all the tutorials, then in the last video I'm going to show how to create a presentation, a better presentation for giving in any of the analysis stream. So in this way I have ended with this first solution of the model of AOC 2012, that is of pressure tank. Thank you very much for watching this video. For the solution of other problems which provided for AOC 2012, keep watching the other videos. Thank you very much.